we want to show that cosine of the product of cosine xk, k from 1 to n, is always bigger than sine of the product of sine xk, k from 1 to m. N and m could be different. And of course, here every xk is real number. So before we even attempt to prove this one, maybe using mathematical induction or something else, let's just consider a simple case where if we have two angles, alpha, beta, both non-negative, and their sum is strictly less than half pi, that's 90 degrees. So can we show that cosine alpha is always bigger than sine beta? Right, notice here the status of alpha and beta are equal. Right, so so before we go and prove it rigorously, maybe let's have a look at the intuition. So here I have a unit circle, right? So 0 to half pi. So maybe let's consider some extreme cases where alpha, let's make it 85 degrees. So beta, right, cannot be 5 degrees because their sum is strictly less than 90 degrees. But maybe let's just choose 4 degrees and see what happens. So here I consider cosine alpha, right? Cosine alpha. So 85 degrees somewhere here maybe. And cosine alpha down here. So this length is cosine alpha. But when you consider beta, sine beta, right, 4 degrees right here. Right? That's this length. Right? So this length compared with this length. But notice this degree is only 4. This degree is only 4. But this degree, because this degree is 85, so this degree is 5 degree. Right? Slightly bigger than this one. Right? Slightly bigger. This one is a little bit smaller. So this length has to be a little smaller than this one. Right? So sine 4 degree has to be a little bit less than cosine 85. All right, so yeah, so intuitively no problem. So which leads us to the slightly rigorous proof where we can take advantage. Like the key here is this condition. Right? We also consider the fact that sine x is increasing function between 0 and half pi. Right? Like I said, because this condition leads to beta is less than half pi minus alpha. Like I said, because of the increasing function of sine from 0 to half pi, therefore, when we apply sine, beta has to be, because first of all, beta is in between 0 and half pi, obviously. Right, half pi minus alpha is also obviously between 0 and half pi. So less than sine of half pi minus alpha. Right? Then we apply the sine sum or sine difference, angle difference formula. Sine half pi times cosine alpha minus cosine half pi times sine alpha. Right, notice cosine half pi is right here. Right? This length, 0. 0. So that is sine, that's one term, cosine alpha. Which one is bigger? Sine is smaller, cosine is bigger. Right? So cosine alpha is really bigger than sine beta, as long as these conditions are satisfied. So then we just implement to our desired result here when we have a finite product there. I say, because as long as we can show that if we treat the because we need them to be positive, so absolute value of cosine x1 times all the way to cosine xn plus the absolute value of sine x1 times all the way to sine xm. Now, these two angles, so their sum is less than half pi. Right? I say, first of all, this is less than or equal to apply the absolute value to each cosine. And absolute value of each cosine is less than or equal to 1. So get rid of everything else. Only keep cosine x1 absolute value. Right? Likewise, absolute value of sine x1. Again, can we, after loosening the inequality, can we show it's less than half pi? Right? So here I apply there is this thing called AMGM, or arithmetic mean. If A, B, and are non-negative, then we always have half of A plus B is less than or equal to the half of A squared plus B squared square root. Right, we multiply 2 over here. Right, their arithmetic mean is always less than their quadratic mean. So this can be easily verified by taking the square root on both sides and then subtract from there, which is greater than or equal to 0. I'm not going to go ahead and verify that because this is easily verifiable. So applying this less than or equal to 2 times square root of half of cosine square x1 plus sine square x1, which is square root of 2. Right, that's approximately 1.414. And half pi is approximately 1.5 something. So yes, strictly less than half pi. Right? Then we can say, yes, we have 2 angles, both non-negative, whose sum is strictly than half pi. Yes, condition satisfied. Right, so we can confidently say that cosine, the absolute value, k from 1 to n, cosine xk, is always strictly bigger than the sine of the absolute value of the product k from 1 to n sine xk. Okay. But here we don't even require the absolute value. It can be still true, right? Because first of all, notice cosine is an even function. Right? So with or without the absolute value, this is always the same. Right? The question is that the right-hand side. Right? When there's no absolute value, right, the inside finite product may be negative. Right? Some of the sine x3 might be -1, -half, whatever. Right? But overall, because each absolute value of each sine is less than 1. Right? So without absolute value, they cannot be lower than -1. The inside the angle cannot be lower than -1, right? Which is around here. Right? So therefore, the sine value has to be, in the worst case scenario, sine value might be negative something, less than -1, right here, there, right? Between a little bit bigger than -1 and less than 0 in that case. But this one is still bigger, right? Because this inside product, that's the angle, right? This angle, right? So maybe sits somewhere here, cannot be bigger than half pi. Cannot even be half pi. Cannot be over here. Therefore, cosine cannot be negative. Always positive. Strictly positive. Because it cannot reach half pi. It may be sit here, but still strictly positive, no matter what. Right? So this cosine is always strictly positive. Right? This might be 0. This might be negative. Right, but in either case, this is always bigger. Right, not to mention with the absolute value. Right? No matter if this is positive, negative, this one is always bigger.